Hello and welcome to another episode of the Dongfang Hour China Aerospace and Space News Roundup. This for the week of the 31st of May to the 6th of June, 2021. I'm Blaine Curcio, joined as always by my co-host, Jean Deville. Before getting into this week's 4 news updates, a special shout out to our good friends at Go Taikonauts and SpaceWatch.global, 2 excellent sources for space industry news. This week, we bring you a couple of updates from China's plethora of commercial launch companies, some additional information on the Tianzhou cargo vessel that is currently docked with the Tianhe core module of the Chinese space station. But first, a review of the launch of the Fengyun 4B meteorological satellite from the beginning of last week.
Ladies and gentlemen, we are honored to welcome you aboard the Dongfang Hour. Please make sure your seatbelt is securely fastened. Thank you.
女士们、先生们，预计空中飞行时间2小时15分钟，我们预计在当地时间下午6点25分左右到达。
So June 3rd saw the launch of the Fengyun 4B meteorological satellite from Xichang Launch Center on board a Long March 3B. The satellite is the latest in China's Fengyun constellation and is the second Fengyun 4 series satellite to be launched into geostationary orbit, joining the Fengyun 4A satellite, which was launched in 2016. We saw an article from China Space News that gave a deep dive into the Fengyun 4B satellite, noting that it is the first operational satellite in the Fengyun 4 constellation, with Fengyun 4A having been an experimental satellite. The Fengyun 4B satellite is equipped with, among other things, a fast imager, a radiation imager, an interferometric infrared detector, what a mouthful that was, and a space environmental monitoring instruments. The fast imager is capable of taking true color snapshots of an area of roughly 2,000 kilometers by 2,000 kilometers, which is well suited for capturing relatively small targets such as typhoons or sandstorms or other such things. The Fengyun 4B satellite will have roughly double the resolution of Fengyun 4A and is able to observe an area of about 1,000 by 1,000 kilometers in about 15 seconds. During the 14th five-year plan period, which is 2021 to 2025, China plans to launch one more Fengyun 4 series satellite, likely to geostationary, as well as multiple Fengyun 3 satellites to polar orbit. This is part of a bigger increase in emphasis on meteorology satellites, which may be in part due to the fact that the Chinese government is becoming more serious about issues like climate change and environmental conditions more generally. So earlier this year, for example, we saw an announcement of the Atmospheres constellation, so Daxi, which aims to launch multiple satellites for monitoring different atmospheric pollutants. So just a little bit more about the Fengyun program in general. So Fengyun is one of China's oldest space programs, with the first Fengyun meteorological satellites launched all the way back in 1988 and 1990. Since then, we've seen a total of 18 Fengyun satellites, primarily launched into polar orbit, but also some into geostationary. Not all of these 18 satellites are still in service, and it is useful to distinguish between the 2 generations that are subdivided into a sun-synchronous polar orbit and geostationary orbit series. So Fengyun 2 and Fengyun 4 are geostationary. Fengyun 2 was the earlier generation. Most of the Fengyun 2 satellites either have been or are in the process of being phased out. And then we have the Fengyun 4 satellites, just mentioned, of which 2 are currently in orbit. The Fengyun 4 is the new generation, and it's based on the much larger, heavier SAS 5000 satellite bus, which is 5,400 kilograms of total mass, compared to about 12 or 1,300 kilograms for the Fengyun 2, and that SAST bus is built by SAST, as it were. The other part of the Fengyun series, so Fengyun 1 and Fengyun 3, are weather satellites in sun-synchronous polar orbit, and the Fengyun 1 satellites have been phased out, while the Fengyun 3 satellites are currently operational. One other noteworthy point about the Fengyun series, and then I'll turn it over to Jean for his analysis. We did see back in 2007, the Fengyun 1C satellite was destroyed by an anti-satellite missile test conducted by China, and this created a couple thousand pieces of trackable debris, so like golf ball-sized pieces of debris, and an estimated 150,000 pieces of debris in total. And this caused a bit of a ruckus back in 2007. Among other things, however, it did lead to a pretty cool image from NASA of different orbits that the debris was scattered into in the days and weeks after the test. So that being said, Jean, anything from your side on the Fengyun constellation or this recent launch?
I think you did a pretty good coverage. I just want to add maybe more of a fun fact on Fengyun. I think that weather applications are one of those more uncommon Earth observation subverticals where geostationary satellites can prove actually to be extremely useful. And I say this because most Earth observation applications tend to strive for better resolution, and that usually means that you need to have your Earth observation satellites in lower Earth orbits. And I think typically situations where you're trying to image farmlands or trying to detect or distinguish specific objects on the surface of the Earth. And usually in those situations, you're aiming for resolutions that are at the very least, I'd say below 100 meters, possibly even below 30, 20, or even 10 meters. So I'd say that's the most frequent case. But on the other hand, there are cases where gathering data over the same area of land is important, and when local conditions are changing at a rapid pace. And that's typically the case for meteorology, for weather forecasting, and that's where geostationary satellites and Earth observation have a role to play. So that's the first point. The second point is that just want to point out that the Fengyun 4A and the Fengyun 4B will continuously be able to produce maps of things like visible light cloud coverage, infrared maps, water vapor, aerosols, sea surface temperature, I think even carbon dioxide as well. And what is very cool here, I think, is that all this is able to be done, to be mapped by one single instrument. And, that's a multispectral imager. And just by changing the spectral channel, just by changing, the wavelength, you're actually getting completely different information from the image, from the data you're collecting. So I found that to be very powerful. Thought I'd point that out. And the last point also, Fengyun 4B is equipped with an instrument called the LMI, the Lightning Mapping Imager, which will be able to monitor the lightning activity over China. So cool satellite, Fengyun 4B.
Heck of a microspectral imager. Yeah, holy cow. That sounds pretty cool. And that's a very good point about geostationary for weather satellites. I had not thought about that, but it makes sense to be a bit further away. So, indeed. So moving on to the second piece of news of the week. So we saw from Space Pioneer, also known as Tianbing Aerospace, or Tianbing Kezi, announced on the 1st of June the completion of their full system hot test of the Tianhua 11 engine. And the company notes that the engine aims to be the first reusable liquid Kerolox engine in China, which we have some discussion about. And according to the article, around 80% of the parts in the Tianhua 11 are 3D printed, which is sort of sounds rather similar to the company Relativity Space over in the US in terms of the emphasis on 3D printing. So just a little bit of background on Space Pioneer. As we've discussed on the Dongfang Hour over these months, the company has had a very, very impressive 14 months or so from a fundraising perspective. And that's not to say that fundraising is not the end-all be-all, but they've completed 3 funding rounds and apparently have made some progress on the Tianhua 11. The company was founded by the former CTO of Landspace, Kang Yonglai, and they do have some similar characteristics to Landspace in terms of target market and kind of their value proposition, which is to say they're trying to provide an environmentally friendly rocket engine, such that rocket engines can be environmentally friendly. The company also appears to be heavily supported, or at least rather heavily supported, by various government entities. So in several of their funding rounds, they have received funding from the Zhejiang University VC sort of Innovation Fund, and they also appear to have some relationship with the municipal government of the city of Tianjin. So that being the case, I will turn it over to Jean, who knows rockets far better than I. So Jean, how about the Tianhua 11 and Tianbing?
I must admit that with this piece of news, I'm getting a bit confused with what the company is actually planning in terms of propulsion technology. It does get a bit complicated, so let's try and piece things together during this episode. So first thing, let's some background on Tianbing. Previously, Tianbing had communicated a lot on the development of 3 rocket engines. That's the Tianhua 1, which provides 1 kilonewton of thrust. There's the Tianhua 2, which provides 10 kilonewtons of thrust. And ultimately, there's the much larger Tianhua 3 engine that provides 30 tons of thrust. And all 3 are supposed to be based on an in-house green monopropellant called HCP. And as we mentioned in episode 30 of the Dongfang Hour, HCP, this monopropellant, would be a massive leap in technology, considering that monopropellants, so far as I know, have only been used in upper stage engines, in attitude control engines, or in turbopumps. And back in the day, we already had some doubts about the ability of such a new company, Tianbing was founded in 2019, to able to, put together such a novel technology with such an aggressive timeline. I say aggressive timeline because they're planning to have the first launch of their Tianlong-1 rocket in 2022. And now today we see this piece of news discussing this Tianhua 11 engine, which I must admit I haven't heard of before, and which apparently provides 30 tons of thrust, just like the previously mentioned Tianhua 3 so-called HCP fueled engine. But, the Tianhua 11 here is mentioned as a closed cycle Kerolox engine based on an oxygen-rich preburner. And that in itself is already a technological feat, considering that oxygen-rich preburners, just more generally, closed cycle engines are not a piece of cake, especially for a startup that's 3 years old. So yeah, that's the first point. The article also mentions that this Tianhua 11 engine uses HCP gas turbine startup technology. And that there you have it again. This HCP technology phrase is thrown at us. So in the end, I don't really know what to think about this Tianhua 11 engine that I've never heard of. Is this a separate 30-ton thrust engine that's being developed by Tianbing and that's based on more traditional Kerolox, technology, although with an innovative closed cycle architecture, that's for sure? Or is this Tianhua 11 just a rebranding of the previously so-called HCP 30-ton thrust Tianhua 3 engine, and that all this HCP discussion was not on the main propulsion architecture, but was just regarding the, running the turbopumps? Is that it? So I honestly here I have lots of questions. I don't really have many answers. I must admit I am not a big fan of Tianbing's way of communicating because I think there's a lot of confusion. And I also think that, in their article, they claim that the Tianhua 11 is so the only reusable Kerolox engine in China, 国内唯一可重复使用的液氧煤油发动机, and that is totally untrue because you have also other companies, commercial companies such as Deep Blue Aerospace or Galactic Energy, which are also developing Kerolox engines for their vertical takeoff, vertical landing rockets. So yeah, that's my rant here on Tianbing. Hopefully they can clarify a little bit what they're trying to do. A cool company nonetheless, HCP monopropellant. That would be cool to see.
They may get some hate mail from Galactic Energy and or Deep Blue Aerospace if they come across that article, or at a minimum, just kind of what is this, guys? This is pretty black and white. So we'll see. But to your point, probably a number of different reusable Kerolox engines that are going to be developed, or that are being developed. So indeed, that's a little bit confusing. But not the only launch company to have an update this week. So
absolutely.
Some more interesting things happening down in Guangzhou, I suppose.
Yes, indeed. This week, we also heard that the Chinese Academy of Sciences spin-off CAS Space announced that it had begun the design of its small to medium lift solid-fueled rocket, the ZK-2. And this was in an interview with the China Daily on June the 4th. Now, the existence of the ZK-2 is not actually news. We were already aware of it. It was public information. And for example, CAS Space had shown a launch vehicle roadmap at CCAF 2020 conference, where we could see the ZK-1, the ZK-2, the ZK-3, and the ZK-4 rockets. Now, taking a step back here, putting things into perspective, CAS Space is a company going for what I'd call a solid plus liquid propulsion rocket strategy. And what this means is the ZK-1 and ZK-2 are solid-fueled, while the ZK-3 and ZK-4 are liquid-fueled, medium-lift, vertical takeoff, vertical landing rockets that bear some resemblance with SpaceX's Falcon 9 and Falcon Heavy. And up to now, we knew that CAS Space was mostly absorbed by the preparation of their inaugural launch of the ZK-1 sometime in September this year. But the increasing attention that they're putting on this ZK-2 is interesting in itself. And that's because, well, the ZK-2 is quite a big rocket. It will have a core stage, two side boosters with a diameter of 2.65 meters. It will be approximately 40 meters tall. It will have a liftoff weight of 343 metric tons, and it will be able to put 3.5 tons-ish of payload into sun-synchronous orbit. And the main thing here to look at is that 3.5 tons, that's a huge payload capacity for a solid rocket. And as mentioned by the China Daily article, this would make the rocket the most powerful solid-fueled rocket currently in operation. The second one being only Arianespace with their Vega rocket, which puts 1.5 tons into SSO, although I think future versions, the Vega C and the Vega E, will put something like 2.3 tons into sun-synchronous orbit. So This huge payload capacity for a solid fueled rocket, this is a significant difference in strategy compared to other Chinese commercial launch companies. Most of them have all of them have literally selected liquid fueled propulsion technologies for their small to medium lift launch vehicles. And even X-Space, which is a CASIC spin-off and launch company, which has this solid fuel DNA and that initially had this roadmap with only solid fuel rockets. Even those guys have decided to look at liquid fueled propulsion, and that's their Kuaizhou 2 series. And so yeah, it will be interesting to see what market they can get with such a rocket. And it's also interesting to note that their own ZK2 rocket, solid fuel, is in competition, I think, in terms of payload with their ZK3 liquid fueled reusable rocket. So it'd be interesting to know how that turns out.
For sure. And it will also be, it'll be interesting to see, what market share are they able to win with this, get ready for the American English, the ZK2 rocket. And will they be able to compete with liquid fueled reusable rockets from companies like Landspace or iSpace or Galactic Energy? So clearly CAS Space is aware of the advantages of VTVL, and they've also been developing indirectly their own liquid fueled rockets in parallel with the ZK3 and 4. CAS Space's sister company, CAPT, is developing the Xinhua 1 Kerolox engine. So again, indirectly developing the liquid rocket engines, which we've discussed in previous episodes a few times. And we did see as well last week, XAPT released a video with some nice visuals on that Xinhua 1 engine. Nothing new really, but nonetheless, the thrust of the engine, about 20 tons, makes it a good candidate to be fitted into the ZK3 or ZK4A rockets, which should have a payload of around 1.5 tons and 4 tons, respectively. So just a couple of kind of broader points about the interview itself that we are referring to here, discussing the ZK2. So the interview was conducted with the CAS Space founder and his senior rocket scientist, Yang Yiqiang, and he mentioned several things that I found pretty noteworthy. So first, he explicitly mentioned that the ZK2 would be more powerful than the Long March 2C and the Long March 4B, and that the ZK-1A would be more powerful than the Long March 11. And these may be factually correct statements, but nonetheless, it's interesting to see a sort of commercial company directly saying that our rocket is going to be more powerful than the state-owned rockets. This is something that you tend to not see, and we've talked about at length this idea that a Chinese version of SpaceX is rather hard to imagine, if for no other reason than the fact that SpaceX has basically said NASA and the ULA and others make very expensive rockets, and we can make equally good or better rockets for less money. And in the US, where you have a more kind of open innovation ecosystem that is quite okay, and in China, it's rather harder to imagine commercial companies coming out and saying that the state-owned incumbents are doing a suboptimal job. So again, first point, it's interesting that Yang Yiqiang specifically mentioned that CAS Space is planning to build rockets that are more powerful than specific CAS rockets. So I guess the other thing of note is the apparent target market for the ZK2 rocket. So Young mentioned two areas in particular, so namely LEO constellations, which is not a huge surprise given that's a big source of demand moving forward, and also CAS, Chinese Academy of Sciences, science and technology satellites, noting in the case of the latter that, I quote, the top science body, the CAS, wanted its own rocket research and production capabilities. And this is something that we've discussed before in the context of CAS Space, that probably one of the markets they will be going for is this kind of captive internal Chinese Academy of Sciences demand, because the Chinese Academy of Sciences does launch a pretty large number of satellites in any given year. So just last point on my side, that Yang specifically mentioned that the country's rocket manufacturing facility is in Guangzhou, which is the country's southernmost carrier rocket production facility, did he say. And it's probably reading too much into it, but it's plausible that, being southernmost, it's close to Hainan. It's probably reading too much into it to think that means it's close to Hainan. But digressing, Yang did mention that it would be produced in Guangzhou. And just the sort of latest, endorsement that we are seeing of the still relatively small but growing very quickly Guangdong space industry ecosystem. So that being said, nothing else from my side on CAS Space. So, Jean, do you want to take us into the Tianzhou 2 story and round out the week?
Yeah, and there's actually a good segue here because I agree that it's rare to see Chinese companies comparing their own products to, their own systems to the Long March or just any state-owned product and saying that we're doing better. And usually the comparison does take place, but not with the Long March, not with state-owned systems, but with U.S. systems or foreign systems. And we saw this a lot with Tianzhou, for example. There are a lot of articles this week on how, Tianzhou has one of the highest payload capacity among the cargo resupply spacecraft, things like that. So that's usually how it takes place. And so on Tianzhou 2, as we all know, the Tianzhou 2 spacecraft delivered 6.8 tons of cargo to the Chinese space station last week, and that's something that we covered in the past episode. And over the past few days, more information on the Chinese internet was unveiled on various things, and notably on what was on board and how the cargo was packaged, and that's what we want to share today. So first of all, there are images that show the pressurized orbital module with 40 square-shaped compartments, and these are used to house and protect the cargo during the entire launch phase. An article by the Chinese Aerospace News also mentions that there were 160 packages that were fitted inside these 40 compartments. And among them, there were 2 spacesuits, and that's the indigenous Feitian spacesuits, which are used for extravehicular activity. Each of these suits weigh about or over 100 kilograms each, and together they took up 8 of the 40 compartments that you can see on the image. There were also 5 bundles of 20 gas tanks containing very precious gases when you're in space, like oxygen and nitrogen. There are also a dozen water tanks for the use of the taikonauts. And ultimately, the article also mentions food, clothing, cleaning wipes, laogamma. Okay, not laogamma, but the rest is true.
If only.
As well as some, scientific payload and some backup components for the space station. And all these bits and pieces were placed very carefully inside these 40 compartments, taking into account their mass in order to make sure that the center of gravity of the spacecraft is maintained within a predefined limits. And last point I wanted to mention here that was put forward by the article is that the Tianzhou 2 spacecraft also carried 3.5 tons of propellant, and this was inside 8 different 400-liter tanks. And among these 3.5 tons, there were 2.5 tons that were meant to resupply specifically the space station. And last point, again, on power supply this time, the cargo spacecraft also has 2 large solar arrays, and this we already knew. They deployed correctly and they're connected to lithium batteries. But the article mentions that also the Tianzhou spacecraft is able to power the Chinese space station if it has any excess power production. And typically, a situation where that could happen is if in the Chinese space station there's a space experiment that's requiring extra power, in which case, the Tianzhou spacecraft can sort of provide the extra amount of power required. And it can actually happen the other way around. If the Tianzhou requires a bit of power, the Chinese space station can provide that power to Tianzhou. So power can be provided both ways, which is pretty cool, I think.
And definitely very helpful as a backup if you're up in space. And I'm halfway joking when I say I would have to be thinking, do I want oxygen or Laogan more if I'm up there in the space station? And just one very, very last point on the human space flight element, and I think we're under our 30 minutes, so it should be good. But so I did see another article this week that was it was Yang Liwei, so China's first astronaut, or first taikonaut in space. He's currently the director of the human space program. He had mentioned that there were 16 backup taikonauts being trained in the event that any of the 3 taikonauts that will be going up later this month, in the event that any of them could not make it. And apparently Yang Liwei, at age, I think, 55, mentioned that he was one of the 16. It was a very emphatic quote, and I don't know how true that is, insofar as I don't know if Yang Liwei is in physically good enough shape to go up to the space station tomorrow, but interesting to see, and possibly a sort of patriotic, sort of a patriotic reference, I guess, with having China's first astronaut still being in good enough shape to potentially go up to the space station if duty were to call. So,
but it's possible. We had John Glenn orbit the Earth in 1962. So John Glenn, the U.S. astronaut, and he flew again, I think, in 1998 on board the space shuttle. He was age 77. That was criticized at the time, admittedly, but hey, 77. I think 55 is okay for Yang Liwei.
That's a fair point, especially if he's been having a lot of like vegetables and laogan ma all of his life. He's probably in pretty damn good shape. So yeah, maybe I eat my words. I take that back. And Yang Mi Wei, if duty calls, I'm sure he's ready to go. And so either way, we're looking forward to bringing those updates of the Shenzhou launch later on this month. But that being the case, I think that's all the updates for this week of the 31st of May to the 6th of June. Thank you very much for watching, and a big thanks to the plethora of new fans that have apparently discovered our channel over these past several days. I'm happy to see it. I'm Blaine Curcio, and this has been another episode of the Dongfang Hour China Aerospace and Space News Roundup.
Thank you for watching. See you next week.